Solving linear inequalities. When we solve linear inequalities, we are looking for all the values of this function that are greater than 4. So what we want to do is this creates a linear equation. So what I do is I'm kind of going to ignore the inequality right now, and I'm going to graph this line. So how do I graph that line? I'm going to write my equation in y equals mx plus b form so I can graph the slope and y-intercept on our line here, on our coordinate grid. So I'm going to solve this for y. So we have 2y equals this 3x is going to become a negative 3x plus 4. I'm going to divide everything by 2. Okay. And so now what I'm going to do is I'm going to draw this line. So using a straight edge, I have a y-intercept at 2. I have a slope of negative 3 over 2, so I'm going to go down 3. 1, 2, 3, and to the right 2. 1, 2. I'm just going to do that again. Down 3, 1, 2, 3, 1, 2, just so I get a good view of what this line is looking like, and I can do the opposite in this direction, and so on. So what I want to do is I want to graph this line. But when I graph this line, I don't want to graph a solid line. I want to graph a dotted line because I do not want to include all of the values that are equal to 4. I just want to include the values that are greater than 4. So my actually is not going to include this line. So that's why we draw it dotted. Okay. So there is my line. So now what we want to do is we want to figure out, well, are all of the solutions the bottom of this line, or all the solutions that make this inequality true to the top of this line? So what you want to do is you want to choose a test point. And your test point has to be a point anywhere on the grid, not on the line. Not on the line. So an easy test point all the time is like 0, 0, because that's easy to evaluate. Unless 0, 0 is directly on the line, you can't choose it. So in this case, I'm going to pick a test point of 0, 0. So what I want to do with this test point now is I'm going to take this test point and substitute it in for my x and y value in my inequality and ask myself, is the inequality true? So I'm going to take 3 times 0 plus 2 times 0, and I'm going to ask myself, is this value over here greater than 4? This is the question I'm asking. Well, 3 times 0 plus 2 times 0 is obviously going to be 0. Is this a true statement? Is 0 greater than 4? And no, this is not true. So look at my coordinate grid here. Here's my 0. This is not a value that is less than or greater than 4. So what I want to do is I'm going to shade in the area of my graph that is opposite of this point. So I want all the points that are true to this statement. So any point inside this shaded region would be a possible solution to this inequality. So we're no longer finding the points on the line, we're talking about all the solutions in this area. So if I were to pick this point 4, let's say, and 5, this should be a possible solution that makes this inequality true. So if I were to check that, if I take 3 times 4 plus 2 times 5, is that value 4? Well, yes it is, because 12 plus 10 would be 25. It's greater than 4. So all of these points, and there's infinitely many of them, all of these points in this shaded region satisfy inequality. So that's why we want to shade in this area, because we're actually including all of these points, not just one of them, we're including all of them. Okay, so that's the difference between an inequality and an equation. Equation, you're just solving for one point or one value, and you're looking for infinitely many solutions. And that is how you solve a linear inequality.